Hey, what's up YouTube? My name's Kevin. I'm an engineering designer and 3D modeling enthusiast. I'm here to take you on a journey with me. What we're going to do here in this playlist is that I'm going to take you through 23 complex, highly sophisticated parts that SolidWorks has specifically designed to challenge us at SolidWorks World, the largest engineering conference hosted by Dassault Systemes. By the end of this series, you will have a good grasp of SolidWorks Maker and be able to create your own SolidWorks complex parts. Let's do this. Let's look at this part here. So this part here is what I've been kind of looking forward to do out of all these parts, funny enough, because it has draft in it. Now this draft always throws me for a loop. One, because my specialty is actually, plastic design. That's funny enough. But this draft, they have it in both directions, and they have this cut in it. So I'm wondering if this cut is going to be a shell or if it's going to be like a rip feature. I don't know. So let's check it out. Scroll down here, and it's two phases. So the first phase of the drawing. Oh, this was in color. So let's look at this part. So there's actually draft in it too. So that immediately gives me a couple ideas. And it does look like it's symmetrical up and down. That actually makes it much more easier. What's this? Section BB. I'm looking for that BB symbol here. There's that A, BB. Oh, so basically it's just this wall. It's showing you the draft, which is 7 degrees. Let me see here, 7mm wall thicknesses, 15 degrees. More draft here, 7. So the general draft is gonna be about 7 degrees, which is it's okay. It's good. It's a good amount. It's a substantial amount. It will definitely come out of the tool. And then the center here, there's no radius. So okay, I'm gonna do this color coding as well. I actually really like this color coding. 3mm fillets for the green. Is the purple different? Edges apart and inside of the pocket is shown. So they don't have it as two different radiuses. That would have been cool. Fillets removed for clarity. That's pretty cool. Okay, so unlike the other parts, which looked like, this one actually looked pretty good, but the one for the 2, it's just like, oh wow. And now 2003 version comes out, it looks boom, really different. Oh, actually, let me first check, because I always kind of forget. Go down here, and then this part, it's gonna be in inches. Oh, so there's actually a pretty big part. That's insane. Interesting. I don't know what this diameter mean here. I mean, it's both sides. So I'm gonna use a full. So I'm actually not gonna focus on any one view. I'm gonna have to focus on all 3 of them at once. So the way I'm gonna start this is I'm probably gonna make this shape on the right plane, make this my center, and just extrude this 70 inches. Apparently 70 inches. So let's start that in SolidWorks. So let's go to File, New. So let's press OK. Let's save this. I'm gonna name this one as SolidWorks Mania 2. And remember, all these files are gonna be available for you guys to download. Anything else, make sure this is in inches. Perfect. Save that. Make sure right click on the right plane, and then let's start this. So I'm gonna start here. I'm gonna do the basic shape, and then I'll actually give it dimensions later on. Actually, let's do this. I'm actually gonna build this in half. So I'm gonna go like this. I'm gonna make a straight tower. The reason why I'm make it straight, and you guys will see later on, is that I'll be able to draft all the walls at once, and I won't have to worry about that so much. Oops. Let me make sure this is actually touching here. Trim, trim. Trim. Make sure here to here is connected, and here to here is connected. And let's check out the dimensions. Oh, actually there's gonna be like a center line here of giving the diameter of the hole that's cut in here. So I'm gonna use that as a reference. I'm gonna Control Z it. And I'm gonna keep it like that for now in case they change that on us, which I doubt, but you know, better safe than sorry. So 70 here, and from here to here it's gonna be 7 inches, and there's gonna be a center line here. I'm just going to use that as a reference for now. And this to here, this edge to this edge is going to be 100. And then this to here is 15. This to here is 15. Oops. And now, so here to here is going to be 7. That's a reference dimension, by the way, so that's we're taking quite a risk there. And we're going to extrude that mid-plane 70 inches. Boom. Save that. Now we're going to go top plane. So I'm going to go here. And then in our sketch, we actually made that reference. So here we're going to actually do a pierce. There we go. Make this tangent to this face. There we go. And now, I can actually hide that sketch for now. Here, to there, to here. Not that. Something tells me I'm doing something wrong. We'll soon find out if that's it. Mirror this. I love mirror, by the way. It's my favorite thing to do. Basically means you gotta have to work to do. And then we're gonna get both regions. We're gonna do through all both. Press OK. Now we got that. Sure. Same time I could do that cut as well. What's the dimension for that cut? 15. Something looks off here. Actually, wait. This is the wall thickness from 15. I actually have that wrong. So this is actually 15 and the 7. So okay. So there's one mistake. So let me go back. So here it's not 7. So we're actually gonna make 2 references. We'll make this line here. And it probably would have been better to do like another sketch, but since I'm at this point, do 15 there. The reason why I made it a solid line, because you can't do a dimension like this on a solid line, and now I could change it to a construction line. There'll be no issue. I changed it back, so I want to keep it as a solid line. Yeah, so I could keep that 15 in case we want to change it in future. So I'm gonna do the 15. I'm gonna keep it as a solid line. I thought it would keep it as a regular line. Oops, almost forgot one more dimension, which is gonna be the 7 from the edge. And then let's press OK. Exit and let the sketch rebuild. I know it's gonna break. And we're gonna pick the regions instead. Region. And now we'll go back to this. And this is gonna be really messed up. So this tangent right here, which is not really tangent anymore. It's gonna be tangent all the way to the outside. Here we go. Tangent. And then things wrong here with this line. Why is this line up here? This coincidence broken. Let me fix that here. And let me redo all of the regions. There we go. Okay, I'm gonna do one thing here. We'll go insert, features, split, cut part. I'm gonna cut the part and I'm not gonna consume it. It's gonna leave these two parts. I'm gonna hide one for now. And then what I'm gonna do is I'm gonna go back to the sketch, which is now we're gonna classify it as master sketch. And I'm actually gonna do another center line. And this center line here is gonna indicate, and I wish I did this on the opposite side as well, which I could probably do with this mirror about. There we go. I'm gonna indicate with this. I'm gonna give this a dimension of 7 now, which is gonna make it that wall. I'll make sure it contacts this point here. And it's gonna break it again. So we're gonna include this region. And this extrude cut, I don't know why I gave it the 15. I'm gonna remove that and then just make it pierce the line in that sketch. So that sketch could be our master sketch for almost everything. So we're gonna get this, we're gonna touch that, we're gonna pierce it. And now it makes it, it gives it a relation. So what I'm actually gonna do, I'm not sure if this is the right way, honestly. I'm gonna get there. Make sure this is concentric. I get this line here. Get this line here. I'm gonna offset 7. Oops. I guess I can only do one at a time. Offset 7. Offset 7. Actually, before I complete this though, I'm gonna scroll back on this. I'm gonna hide this. And then what I'm gonna do is I'm gonna actually make that equal. Insert, features, split, cut. I'm gonna cut that out. Well, I'm not gonna cut it out. I'm just gonna split apart, hide that, go back to my sketch, go to this sketch, convert entities, and then trim. Okay, trim. Okay, cool. And what I'm gonna do is I'm gonna make this visible, which is gonna be the top plane. Extrude cut. I'm gonna pick a direction, which is gonna be this direction. I'm gonna go offset from surface. I'm gonna do offset from 7. And press OK. Oops, forgot one thing. Our 7-degree draft. I'm gonna do the honest thing and consider the opposite side a completely different side. So I'm gonna get that sketch I use. I'm gonna split this apart. Split. Hide that. Hide that. Go to the same sketch. Make my master sketch visible again. Make sure this is concentric. And then touch that. There we go. Make this concentric. And then do the same exact thing. Offset 7. Offset 7. Reverse this one. Get this line, convert entities. This is so cool. This is SolidWorks Maker. This is $10 a month. It's an amazing deal. I love it. And it's all the power of SolidWorks, majority of it, in this cool little, bundle. You get other software with it. Let me just pick the line. Let me pick the surface, which would be the top plane again. The draft, 7 degrees. Then let's hide this. There we go. Save. Show that, show that, show that. Oh, let's combine all the bodies first. Combine. Oh, not all the bodies, just the top and bottom. This one, this one. Okay. And what I'm going to do here is I'm going to do another draft. From here, 7 degrees. Right click, select tangency. Make sure this is pointing up. And then apply. Do the same thing to the bottom face. Draft. Select the faces. Select tangency. Make sure it's in the right direction. This is the direction to pull. And then draft. And I think I made a mistake though. So this draft here that I just did should have been at a different level. So, okay then. So what I'm gonna do here is I'm gonna do something that might break the tree. I'm gonna pull this up. So first I'm gonna see how clear it is. Oh, so this level stage right here, right before the split, is under the split one. Looks like the best place to put them. So let's put it under the split one. Under the split one, and boom, 7 here. Consistent. Ha 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 ha. And then let's combine these. So let's add a color to this. Make it all pretty. Edit. It's that yellow color. There we go. And then the radiuses are 3mm fillets. That's funny. That's 3mm, and then it's 3 inches here. Yeah, it's 8 inches, and then it's millimeter radiuses. And you know what? I think this was supposed to be modeled in millimeters, but the drawing says inches. So there's a good lesson here. The good lesson is that make sure your drawings are in the correct units. You know, you don't want to be blowing up any space shuttles that you might be designing by just because your dimensions are different. So I'm just gonna do the first one in here, which is gonna be these radiuses in here. I'm gonna separate these. I'm gonna do the same thing on the opposite side. Oops. I think I clicked something wrong. Yes, I did. I want faces. This face, and just these 2 inner edges. Oops. Not yet, not yet. Okay. Press OK. Press OK. And then the inside color was a green. The outside was purple. The inside was very cool. So change this fillet. The green. Change the other fillet to purple. Cool. And there it is. It's in inches. I feel bad, honestly. I'll probably remodel this up in millimeters as well. Dimensions are in inches. Yeah, dimensions are in inches. It says it there. They actually do a couple configurations, and they do numbers. So they have the default B, C, and D. So this is a good thing because I get to show you guys how to do an Excel driven configurations list. You need an Excel installed on your computer to be able to do this. If you don't have it, you're gonna have to build every one of these configurations out, and I don't think Excel is hard to get nowadays. So let's do the Excel sheet, and if you guys want it the other way, you know, put it in the comments and I'll do it the other way as well. Okay guys, so now we're gonna do the configurations of this. It's gonna be several configurations, which is gonna be this large hole diameter is gonna change 4 different versions. The distance between center holes, which is going to be this one right here, is going to change into another 4 versions, and the top slope angle is going to change. And this is a great example to show you guys configurations being created from an Excel sheet. So this is super exciting. I love doing this because this is the part that wows people when they see it. It's like, oh my gosh, you have so many levels of, you have so many designs, and you created your model in such a smart way that you're able to change it without breaking the tree. So let me show you guys how to exactly do that. I'm going to save this first. Insert tables, Excel design table, auto create. We're going to leave everything. I'm going to click that. We're going to leave everything mostly as default. Press OK. And then select all of these through. Shift collect, or shift to select all of them. It's okay. And now we have all the parameters in this. So what we're going to do is we're going to call this one B, C, and then D. And then 2 of these are angles. And I'm not too sure which ones they are. I got to eliminate one of these. So let's get out of here first. It's going to generate your 3 configurations. And then I'm going to go to that sketch. Edit sketch. Fit. There's 3 15s in here. This 15 is going to be D6, dimension 6 sketch 1. So that's the one that we're not going to change. So go back to the table, under tables, edit table. And maybe bring in a couple of extra things. Color this is fine. And then that D6 is not the one we're going to change, so we're going to change these 2. I'm going to copy these 3 cells over. And then let it auto build. And I guess I could have made it symmetric, but that's fine. The way we did it, in case it's ever changed. I mean, if it did change, that would have been a crazy one, but no, it is symmetric. And then you could just go through all your designs. You can see the differences in every one of them. Gets longer and longer apparently. That's pretty cool. So yeah, so that's the design table in SolidWorks with Excel sheet. Caveat to that is that you do need Excel to be installed on the same system as SolidWorks, just because to use it. If you guys want to see it the other way, without the Excel being installed on your system, let me know in the comments below. It's basically like the other parts. You're just creating them one by one. With the Excel sheet, you can make it so much more faster and make way more different variations, and even use the power of Excel with the equations to make some crazy equations up and really go ham on this. So here's this part. If you guys like the video, well, actually before I end this off, let's go to evaluate mass properties. Let's go to the default one. I'm only going to do the default one for this time. You guys remember, you guys gonna have full access to this model. You guys go pick up the model, links in the description. You guys can compare it against your own model, and then let me know if I made a mistake. I'm gonna check this against the solutions video, and then if there is a change I need to do, I'll add it on to the end of this video, let you guys exactly know what I made a mistake in, and show you how to fix it inside the model, and then I'll update the model as well. And yeah, so it's like I said before, if you guys like the video, like, subscribe, and give me your input in the comments below. Let me know if you guys would have tackled this some other way, if you guys like the way I did it. Maybe you guys know a tip I don't, or if you guys need more advice or any help with this model, let me know. So yeah, this is the part. This is who I am. This is what I do. I want to help you guys, and I like doing this kind of stuff. Teaching is my passion. Yeah, subscribe, like, follow me along on this journey, and always design amazing things, guys. Okay, peace.